equals X naught.
Is that like the first chapter that they got last week?
I have no idea. I don't know what was going on last week.
So this is the one for today.
This is some of what you sent me from today. These are some pictures from today we can go through.
Okay.
Is that what you want to do? It doesn't matter to me because it's all the same. I mean, it's
Because wait, I'll pull up the. Did I look at the homework or just?
we could do homework problems, sure. Doesn't really matter. Like we can for sure.
I think the first chapter is displacement, time, and average velocity. Then it instantaneous.
Instantaneous. Yep. Rate of change.
Then finding velocity on xt graph.
Yep.
And then the 2.3 is average and instantaneous acceleration.
Right.
Average acceleration, then instantaneous. Finding acceleration on Vx minus t graph or an x minus t graph. And there's the 2.4, motion and constant acceleration. And there's freely falling objects, that's 2.5. And 2.6, velocity and position by integration.
Okay, so what do you want to work on? Because like each of those sections is like your calculus. There's 7.1 calculus is like 2.1 physics. Like there's a lot in there. So pick one, or like if you want to send the homework problems, we can look at those together. Whatever you would like, or I can make up problems. I don't care, but I need more direction than chapter 1 of physics because there's a lot here.
You can't access the homework.
I do that. I do it on another computer, so I don't have access to it right now.
Oh. Okay, so the homework is which one? The introduction to mastery physics?
Probably not that one. That's just more like here's how you get started.
Physics primer or no?
We could do that. I mean, that would be useful. That's more like math stuff usually. I think it was math. I don't remember. Do you have any problems from class? I mean, because all you sent me was just formulas from the instructor. No problems. I mean, I can make some up, but it's do you want me just to start?
Yeah, it's what is the physics primer that says here? The physics primer.
Well, that's just like getting ready. I mean, that's like some introductory stuff, but it's also like some math stuff that you're supposed to know going into this.
I don't know like where to begin.
Me either. There's the okay, so we'll just start with some things. So delta x is x final minus x initial. Okay, so let's say you're on a track. You're going around a track. Okay. This is your x final and this is your x initial. Like if you start in the same, this is where you start and this is where you finish. You start here, you run all the way around and you finish, you're at the same position. Okay, so your delta x is 0 in this case, start and finish, because your start and finish is the same. But let's say you go ahead.
What is delta x? Is it like
Change in position.
oh, but he changed the position when he started going.
No, if you like, let's say you were here and you ran all the way around and you stopped where you finished, and I didn't see what you were doing. All I saw was where you started and where you finished. It's exactly the same.
Okay.
Okay, so like you're at home, you go to school, you come back, you're at home. Your change in position is 0.
Okay.
But now let's say you go out your front door and you just run. Here's your start. Here's your finish. Your change in position, your delta x. And we'll give this some numbers. Let's say this is 100 meters away and this is 0 meters. Your delta x is 100 minus 0.
Okay.
Okay. Now your displacement is different than your position. Okay, so displacement is and position and distance. These are two different things, and I don't think we want to get in right now, but that's an important thing to think about. So the next concept I usually talk about in physics is change in velocity. Or let's just do velocity first. So your velocity is the distance you travel over time. So if you go 1,000 meters in 50 seconds, your velocity is 20 meters per second. All right. And let's say that's your initial velocity, but at a later time, you travel, let's say you go 5,000 meters, but you also do that in 50 seconds. So that's 100 meters per second when you divide.
So how would they give me the question? Like,
I don't know. They would ask, what's the, we're leading up to the question. Because these are all story problems. They're all, lots of sentences together.
this is a velocity 0?
Initial velocity. This means initial velocity, starting velocity.
What's the difference between that and this? The final
velocity.
That's it? That's the only difference?
Well, yeah, like you start and then later on you have another velocity. Like
Okay.
if you run, you run slower, then you run faster maybe. So your change in velocity is v final minus v initial. So that's 100 minus 20, which is 80 meters per second. So there's this delta x, which is x final minus x initial. There's this v final minus v initial for delta v. And I mean, there's even change in acceleration, which doesn't happen very often, but it's a final minus a initial. So these are all formulas, but they're all kind of the same. Like change means final minus initial. Change in velocity is final minus initial.
Delta x is that's the formula I must memorize.
Well, kind of. I mean, it's assumed that you know this to start this class.
It's x velocity minus x.
No, this is X, the final position minus the initial position.
What's delta v?
Change in velocity. So final velocity minus initial velocity. And then A is for acceleration. Change in acceleration is the final acceleration minus the initial acceleration.
Change in delta x means what? It
Means change in position. Delta X equals change in position.
and delta v change in
Velocity, yes.
and the change in acceleration.
Right.
Okay.
Okay, now there's a lot of different formulas in physics. So like the velocity is also the change in position over the change in time.
Oh. Wait, can you go? I just want to see something.
It's not related to this.
No, it's
I
not.
mean, it is, but it isn't. Like it's just another way of expressing this.
Oh, so okay. Like that one would get me the same answer as this.
Yeah, that yes, they're all the same, but they're used in different contexts, different problems, different ways.
Okay.
Acceleration is your change in velocity over your change in time.
This is all called what? Like
Equations of motion.
equations of- Okay.
All right, so let's say this is where we really need some problems, but we can make some up here. So let's start out with one-dimensional motion. One-dimensional motion. Okay, so a problem could be something like this. A train starts from rest and accelerates at 10 meters per second squared. How far has the train traveled in 5 seconds?
I need to close the noisy.
Say that one more time.
I need to close the kind of noisy. Okay.
All right, so there's a couple of things in here that makes this class really difficult. There's a lot more of these story problems that you have to be able to read and understand, and English second language is tough. Okay, so if the train is starting from rest, that means that its initial velocity is 0. From rest means it's not moving. Is that okay?
So the initial velocity is 0.
Yes.
Wait, so that's the formula? What's this?
Well, we're going to use this formula for this problem.
How far has the what? Has the
X as a function of time equals initial position plus initial velocity times time plus 1/2 acceleration times time squared.
half? From where did you get the half?
This is just a known equation.
Oh, so still you did not plug in anything? No.
No, we're going to, but this is the starting equation.
Okay.
Okay, so again, like maybe a picture would help, but the train is starting here. That's your x0 equals 0, like you're starting there, and later on t equals 5, it's some distance away.
T equals 5.
Like 5 seconds later, it's over here.
Okay.
All right, so we start plugging in numbers, okay? X0 is 0 because it's starting at 0, but that's where we assume. The velocity is 0. The acceleration is 10. Okay, so we just plug some numbers in. Okay, so this is 0, this is 0. 1/2 of 10 is 5. So x of t is 5t squared. So that this is its position function. So we want to know how far has the train traveled in 5 seconds. So we want to put 5 in for t. So it's 5 times 5 squared, which is 125 meters. Is there anything you would like me to cover again on this?
Um, Zero.
Yes. Is there a question?
No.
Okay. So that's like question A. So question B would be like, what is the velocity after 3 seconds? So there's another equation where you can use V of t equals V initial plus acceleration times time. This is another equation that you need to know. So from the previous problem, what is the initial velocity?
Is the equation going to be given, or
You need to know this. You have to know this.
how do I know when to use which one?
Well, that's the whole, that's like the integration by parts. Like you do a lot of practice and you go to class and homework, and then you know how to do you know how to use this one. It says velocities, that's kind of a giveaway, but these are equations that are part of this class. Like if you look at what you sent me on the one of the slides, it already has this equation. The one with the whiteboard.
Yeah.
And so I mean your instructor's like giving these to you. Okay, so what is the initial velocity from the previous part of the problem? The initial velocity is 0.
Okay.
Okay, so V of t equals 0 plus the acceleration is 10 t.
Mm.
Okay, so V of t equals 10 t. So in 3 seconds, the velocity is 10 times 3,
10 is
30 meters per second. Go ahead.
10 is the what? It's the
Acceleration. The acceleration.
how do you know it's 10?
I made it up in this problem. I gave it to you right here.
Oh. 10. Okay. Okay.
Okay, so let's do this. Part C to this problem, because that's how these go. After,
Wait, why did you okay, okay, okay. You multiply it by 3 because it's why?
I asked it for in 3 seconds.
Okay.
Okay, so if the train travels 400 meters, let's see if that's even reasonable. Yeah, it's okay. 400 meters, what is its final velocity? So there's yet a third equation here. There's V final squared equals v initial squared plus 2 times acceleration change in position. So there's 3 equations of motion. There's this one we used in part A, this one in part B, and another one here in part C.
How many equations there are in total? Is it just 3 or?
I don't know, hundreds in this class.
Oh,
Yeah. So there's a lot. So we're looking for final velocity though. We're looking for this one right here. What is its initial velocity? Go ahead.
but how do you know it's this equation? Like, how?
Because that's this class. This class uses this equation over and over again. These are the equations of motion.
Oh, I'm afraid, like in the test or so, or in the quiz or something, I'll use the other equation for.
Right. Well, so, you know, the class you're taking, physics 141, the prerequisite for it is math 125.
Yeah.
So like they're expecting you to know everything there is to know math 125 to be able to do this. So yeah, you know, you take that for what it's worth. But you're gonna have a lot of equations. It's use this equation, then use this equation and get these numbers and work them together. All right, so v final squared is what we're trying to find. V initial squared is 0. The acceleration is 10, and the change in position is 400 meters. So our V final squared equals 8,000. And then you could take a square root of both sides. So V final equals the square root of 8,000, whatever that is, meters per second.
Okay.
All right, so let me see if I can find some more one-dimensional motion problems for us to look at that are challenging enough for this class.
Wait, the 400, you got it from the answer.
I made it up. I just said if the train travels 400 meters.
Okay. Delta X is the distance.
Yes, the change in position or the distance. Yeah.
Okay.
All right, so here's another question. This might be easier because of the stuff you've been doing in calculus. Let's grab this one. This might be worth doing. Okay. If the position of a particle is given by x equals 20t minus 5t cubed, where x is in meters and t is in seconds, when, if ever, is the particle's velocity 0? Okay, so part A, they're giving you a position function. This is your position function. And they're asking you about velocity. And I think you saw this in class today. So the derivative of position, this is derivative, is velocity. So what is the derivative of this function?
So this function is.
This is power rule. This is,
I'm using the power for this for physics.
Yes.
Oh, so it's going to be 19 t
20 minus.
Minus nothing.
Nope. You got to multiply 15 t squared.
Okay.
It's just power rule. It's if y equals x to the n, y prime is n x to the n minus 1 power. It's power rule.
Okay.
Okay, so that's its velocity. Okay, so the first thing is asking, well, when is its velocity 0? So you set this equal to 0.
Hello?
Yes, can you hear me?
Yeah.
Set the velocity equal to 0. So you're setting this equation equal to 0 right here, the velocity equal to 0. So you solve for t. So you move this to the other side of the equation. Divide by 15. So you have t squared equals 20 over 15, and then you take a square root of both sides. And you get some number. We don't really care what the number is, but you get some number. Is there anything in this that is unclear that we should redo again?
I'm just looking at it.
Yeah, they give you this. You take a derivative to find velocity. They want to know when it's 0. So you set it equal to 0 and you solve for t.
Just put it equal to 0. Then how did you solve for t? Square root?
You add 15 t squared to both sides, divide by 15, square root of t squared.
Square root of t squared, which is
So you add 15 t squared to both sides. 20 equals 15 t squared, divide by 15.
yeah.
20 over 15 equals t squared, square root, and you get your answer.
Oh, that's it. Okay. I thought there's a next step. You have to
Nope.
get the square root of 20 over.
Well, you can. I mean, it's a calculator part,
Okay.
I mean, or it may be done by hand, but that, but whatever. So physics doesn't emphasize by hand. It emphasizes like all the steps here. And then if you want at the end, you can put in the calculator, but that's not very important in physics. So B is asking about acceleration. Okay. So to get acceleration, you start with V and you take a derivative. So what is the derivative of this? 20 minus 15 t squared.
The derivative of this is going to be
The derivative of 20 is 0.
yeah, 0 minus negative 30 t. That's it.
Yes.
Yeah.
So your A of t is minus 30t. And it says, well, when is it 0? So set it equal to 0. Divide both sides by minus 30. So t equals 0.
What's the question for B?
It says, when is its acceleration 0?
How do you know? How can you know?
You set the acceleration equal to 0
Yes.
and solve for t.
And 0.
Yes.
Okay.
All right, so let's look at part C. Let me snip this again. Okay, so when is A negative? So part C here. Part C, it says, when is the acceleration negative?
What do you mean by that? Like,
So A of t is minus 30t. Okay, if you were to graph this, it would look like this.
minus 30? How? Minus 30?
Well, it's right up here. We just did it right up here.
Oh,
Minus 30t.
okay.
So this is what the graph of acceleration looks like.
Okay.
Okay, so negative means below the x-axis. See how it's always below the x-axis?
Yes.
So when A is greater than 0, or I'm sorry, when t is greater than 0, let me write this. T greater than 0, because this is t equals 0, and this is it's really the t-axis. It's not x, but they use t in this class. When is A negative? And then C also asks, it says, when is A positive? and it's positive when it's above the x-axis.
Okay.
So this is never above the x-axis. So we would just say never. Never.
Okay.
Okay, so let me snip in another question. Like this is an exam question. This is something you would see on the exam. You actually know enough to be able to do this, but just to get a feel for like the style of what this class is like. You're going to see this on an exam, something like this.
Um, is there like physics 2 after physics 1?
Yes. Yes.
Am I gonna get it? No.
If you spend 8 hours a day working on school, you can get all this. Okay, so like there's a lot going on here, but like this is what you want to focus in on right here. X of t is 9t minus 0.750 t cubed. What is v of t? V of t is the derivative of this. So you got to be able to take derivatives. Remember we talked about in the calculus how important derivatives are. You got to be able to take the derivative of this.
Going to be 90.
9 minus,
O dot t.
without the t, that's power rule.
Okay. So minus 0.750 times 3
I'm serious. That's 2.25 t to what power?
to the power 2.
Power 2. Okay, now let's set it equal to 0. Because maybe it asks where it's equal to 0. So you're going to add 2.25 t squared to both sides.
And divided by 2.25.
Right. Okay, so you divide by 2.25. And you get 4. 4 equals t squared, so t equals 2. Okay, now what about acceleration? Acceleration of time. So we got to go back to this line right here. We got to take the derivative. So what's the derivative of this?
It's going to be 0
0 minus
negative 4.45
t. Yep.
to the power. Yeah, that's
Okay.
it. Equals 0 or no?
We could do that. I was just trying to show you like another type of question you might see. All right, let's go here.
This is to find the acceleration, right?
Yeah, I mean you wouldn't get one exactly like this, but you would be you'd be expected to do problems like this at some.
To find the acceleration, we must find the we must minus what's the 9 is what?
I don't know. 9 is whatever came
Oh.
from the previous line. It's not that important. All right, so I'm just looking here. I found a textbook that's got some questions in it.
Okay.
And this one looks somewhat interesting. All right, a particle travels along the x-axis with a constant acceleration of 3 meters per second squared. It is at x equals minus 100 meters at time, t equals 4 seconds. In addition, it has a velocity of 15 meters per second at a time 6 seconds later. Find its position at this later time.
So
So there's a lot going on here, right? The acceleration is 3 meters per second squared. Okay, and go ahead.
The velocity is 15.
Well, it has a velocity 6 seconds later. So at t equals 10 seconds, it has a velocity of 15.
T equals 10 seconds.
Yeah, because it says 6 seconds later, referring to this. So at 4 seconds, but then 6 seconds later, it's 15 meters per second.
Oh, so T stands for
Time.
T equals 10. And V, the V is 15 meters. Okay.
Yeah.
Okay.
All right. So like there's 3 equations. X of t equals x naught plus v naught t plus 1/2 a t squared. Okay. That's one equation. V of t equals v0 plus a times t. And then there's another one, but we're just going to stick to these two. Okay. So we're gonna actually consider like this to be its starting point.
Wait, I'm trying to get the xt. Wait, this is xt, right?
No, well, this is just this is information. We're gonna maybe substitute some numbers into this equation.
No, like what I'm trying to get, how did you get the x t equals x?
This is a known equation. You have to know this. You're gonna like you come to your class and like this, you always know this equation. It's always going to be used.
That's,
So you
is that t? Or
this is t and this is t over here, and this is t.
the t? Oh, this is t. Okay.
Okay, so like this, we're going to consider this to be x0. So x of t equals minus 100. We don't know its velocity. Okay, but we know 6 seconds later. So t is 6, because that's 6 seconds later.
No, 10?
Plus, well, it's 10 from 0, but it's relative. Like you only care, we're calling this our initial place. It's hard, right? It's weird, different. Remember, we're jumping into a 2 dot question. These are like harder questions, but you got to get a feel for what you're going to see here. The acceleration is 3 and time is 6. So notice the only thing we don't have is V0. We need V0 bad. So we got to go to another equation over here. We're going to go to this equation on the right. So this equation on the right, it says V final, okay, equals V initial plus acceleration times time. This is V final.
That's vt.
15. 15.
Yeah.
You can replace V of t with VF. V0 is what we're trying to find. The acceleration is 3. The time is
10.
nope.
Oh.
6 seconds later. It's 6.
No, 6 times 3, 18.
Yep. So V0 is minus 3. So we take that number, plop it in here. So x of t equals minus 100 plus minus 3 times 6 plus 1/2 3 times 6 squared. Okay, so like this is minus 118, 3618, this is 54. So it's minus 64 meters.
64. How did it get the negative 118?
Negative 100 plus
Oh,
negative 3 times 6.
and plus 54. Okay.
All right, so let me grab some pictures from class here and maybe try to explain, because your instructor is either not doing much and with formula, just like all formulas or not, but so your instructor is trying to show you that there's this relationship between derivatives and integrals in your class. Okay, so I'm gonna try and show you that down here below. So that's what this slide is. So you start with x of t. The derivative of x of t, let me move this over. The derivative of x of t is v of t. So the derivative of position is velocity. The second derivative of position is the derivative of velocity, which is acceleration. So these are derivatives. The derivative of position is velocity, the derivative of velocity is acceleration. Okay, so now that's like calc 1. Okay, calc 2 is integrals. You've been doing a lot of that. So the integral of acceleration is velocity. So if you have acceleration, you take the integral, you get velocity. The integral of velocity is position. Right. So if you go backwards, it's the integral. And that's what we're trying to show here. If you integrate acceleration, it's like going backwards. If you integrate velocity, you get position.
Okay.
All right, so we covered, let me grab this one here. Excuse me. We covered all of these formulas today here. You can see they look somewhat familiar for this. These are your equations of motion.
So is that like the questions, or is that all for formulas?
This is just formulas. And then it looked like you guys started doing some 2.24 question in class today. Whatever this is.
I saw on the yeah.
Right. So this problem here, there was some given information, but the instructor is saying, like, since you're trying to find acceleration, use this formula. Use this formula. See that formula there? It's this one right here. And they're saying solve it for A, and then plug in the numbers. So your V is 20 squared over 2 times 120. You know, getting that number there, and then 120 is there. Something to do with that problem. And that equals the 1.67 meters per second squared. All right. Do you want to schedule a lesson for tomorrow night? I've got some time at, I think, 8. I've got an 8 available. Or we could do something like at 1
Well, because
ish.
I'm having a quiz